I will be taking Docker part 5. If you want to see the other parts, that is 1 to 4, you can go ahead and subscribe to Sayam's channel and look at the remaining parts, that is 1, 2, 3, 4, in which I have explained about what is Docker, why we need Docker, Docker images, containers, how Docker images are different, how containers are different from VMs, a few basic commands, and yes, the documents from Docker docs that will be helpful for you to give this Docker certification as well, as I mentioned. So today I will be covering Docker security. So let's go on, and I will let you know about Docker. When you start a container, or when you run a container, what is that by default that Docker engine security provides you? So here we have few of these things, that is kernel namespaces, control groups, Docker daemon attack surface, and then another one is Linux kernel capabilities. So these are few of the default Docker engine security things. So let's go into each of the items. So first of all, we have kernel namespaces that are created when a container is run. So as soon as you start your container or run, as soon as container is run, so kernel namespaces are created. Also, container process cannot affect other processes as they run in their own namespaces. So each and every container have their own namespaces so that they do not hinder or do not make it affect the other container processes that run. So each container have their own network stack. So as you see on the screen, the second thing that is created when the container run is C groups. So this is also known as C groups. In short, control groups are also known as C groups in short. And it provides resource accounting and limiting. Also, it ensures that no containers exhaust host resources. So when you are running your container, it makes sure that you do not exhaust your host resources. Only trusted users should be allowed to control your moving on Docker daemon. So only trusted users should be allowed to control your Docker daemon. And the next one is Linux kernel capabilities. So Linux kernel capabilities um, are are comes with some of restricted set of capabilities. So when your Docker starts container, it starts container with a restricted set of capabilities. Even the operating system containers don't get full root privileges, even though they are their own operating system, but they do not get the full root privileges. So now what I'm going to do is if you want to learn more about this default thing, so you can go just to this Docker doc link, which I will be sharing shortly. So you can go to this security page, and I will paste after my session. So you can go and deep dive into each of the by default security things. So let's read little about it. So kernel namespaces. So Docker containers are very similar to LXC containers, and they have similar security features. So when you start container with Docker run, so behind the scenes, what is happening is it is creating set of namespaces. So each process, each container have their own set of namespaces so that they do not affect the other processes running on the same server. So namespaces provide the first and most straightforward form of isolation. So this is the straightforward form of isolation. Processes running within a container cannot see and even less affect the processes running in another container, as I stated earlier as well. So each container also gets its own network stack. What does that mean? Meaning that a container doesn't get the privileged access to the sockets or interfaces of the another container. Of course, if the system is set up accordingly, containers can interact with each other through their respective network interfaces, just like they interact with the external host. So now coming to the control groups. Control groups are another key component of Linux containers. They implement resource accounting and limiting. They provide useful metrics, but they also help ensure that each container gets a fair share of memory, CPU, disk, input, output, and most importantly, that a single container cannot bring the system down by exhausting one of the resources. So, if you have provided, suppose you have 4 CPUs, So if it makes sure that one container do not use all the CPU resources, so that it makes sure you can run more containers on the same server. Docker daemon attack surface: running containers and applications with Docker implies running the Docker daemon. So this daemon requires root privileges unless you opt into the rootless mode, and you should therefore will be aware of some important details. So I really highly recommend you to go through this link. I will share this link after my session, and please take time and go through this session. This is very important and basic if you're thinking to go for DCA certification. So please go through these Docker docs. It will be really helpful. So coming to the last default, that is Linux kernel capabilities. So by default, Docker starts container with restricted set of capabilities, as I mentioned earlier. But what does that mean? Capabilities turn the binary, that is root, non-root dichotomy, into fine-grained access control systems. So processes just need to bind on a port below 1024, do not need to run as a root. They can be generated by netbind service capability instead. And there are many more capabilities for almost the specific areas where root privilege are usually needed. So if you want more information, please go through this page, and it is very helpful and beneficial. So now moving on, what I'm going to do is I will be sharing some of the very good practices when of Docker container security, or if you're thinking to run your applications using Docker. So what I'm going to do is I will be sharing some of the very good best practices that one must follow, and I will be sharing the references, the blogs from where I have studied, so that you can just go through that and give a quick look into that. So this will be very short and quick session, and I hope it will be useful for you. So let's learn about few Docker security best practices. So starting from so sorry, starting from the first point. So always try to use the most updated version of Docker. So whenever you are thinking to use Docker or run your applications using Docker, so always try to use the most updated version. So suppose the latest, suppose I'm just taking an example. Suppose the latest version is 18.9.2. So try to take a little one version down of it, not very old version of Docker. So these are some of the best practices. So allow only trusted users to control your Docker daemon by making sure only trusted users are members of your Docker group. So always make sure that your trusted users are members of your Docker group. And I will be sharing one article also for this what this best practice, so that you can go through and you can avoid this daemons attack service. And now coming on, make sure that you have rules in place that give you an Docker daemon, or always try to store your files and directories in /var /lib/docker, and try to use etc docker and docker service, docker.service, docker.socket, or such paths, usr, sbin, runc, and this. Now coming on to the next best practice. So secure all your Docker files and directories by ensuring that they are owned by the appropriate user, and their file permissions are set to restrictive value. So always make sure that you secure all your Docker files and directories, and it should be owned by the appropriate user. Now, coming to the fifth point, use registries that have a valid registry certificate, or the ones that use TLS to minimize the risk of traffic interception. So always try to use a valid registry certificate. Now, next is, if you are using your containers without an explicit container user defined in the image, you should enable user namespace support, which will allow you to remap container user to host user. Disallow containers from acquiring new privileges. By default, containers are acquired acquire only new privileges. So this configuration must be explicitly set. Another step you can take to minimize a privilege escalation attack is to remove the set UID and set GID permissions in the images. As a practice, try to run your containers as a non-root user. UID should not zero. UID not zero. So try to run your containers as a non-root user. By default, container runs with root privileges as the root user inside the container. Moving on to the next point, try to use only trusted base images when you are building your containers. This tip might seem obvious one to you, but the third party registries often don't have any governance policy for the images stored in them. So always try to pull a trusted base image when you are trying to run your container. It is important to know which images are available for use on the Docker host so you can review the content in them. Uh, and moving on to the next point, use minimal base images that don't include unnecessary software packages that could lead to larger attack services. So always keep in mind that you use minimal base images and do not include unnecessary software packages into them. Having fewer components in your container, it reduces the number of available attack vectors. And minimal image also yields better performance because there are few bytes on the disk and less network traffic for images being copied. Now, moving on to the next point, it is implement a strong governance policy that enforces frequent image scanning. So, stale images or images that haven't been scanned recently should be rejected or rescanned before moving to your build stage. Build a workflow that regularly identifies and removes stale or unused images from the containers. So try to build a workflow that regularly have a check on your images if there are stale or unused or old images which are no longer in use. It will be removed from your containers from the host. And the one more big thing is don't store your secrets in images in your Docker file. Try to avoid that. By default, you are allowed to store secrets in Docker file, but storing secrets in an image gives any user access to that image to the secret. So if you're storing your image, your secrets in Docker files or images, so anybody can see that, anybody will be having access to it. So when running containers, try to remove all the capabilities that are not required for the container to function as needed. So you can use Docker's CAP drop capability to drop a specific containers capability. And also you can use CAP cap add to add any of the capabilities required for the proper functioning of the container. So these are very good two functions. Coming to the next point, don't run containers with privileged flag, as this type of container will have most of the capabilities available to the underlying host. This flag also override any rules which you will set using cap drop or cap add. Now next, don't mount sensitive host system directories on container, especially in a writable mode that could expose them to being changed maliciously in any way that could lead to host promise compromise, not promise, host compromise. Now the next point which I would like to state over here is don't run SSHD within the containers. Try to avoid SSHD in the containers. By default, the SSH daemon will not be running in a container, and you shouldn't install the SSH daemon to simplify security management of the SSH server. So try to avoid this SSH thing over here. So try not to map any ports below 1024 within a container, as they are considered privileged because they transmit sensitive data. So always try not to use the ports below 1024. It might transmit the sensitive data. So by default, Docker maps container ports to 1. That's within the range of 49153 to 65525 range. But it allows the containers to be mapped to a privileged port. As a general rule of thumb, ensure only needed ports are open to the container. So try not to open the container which are not needed, open the ports which are not needed. It is make this as a rule of thumb, and ensure that you are not opening any unwanted ports onto a container. Okay. I'm sharing the right screen. I'm just telling the best practices, few of the best practices, and then I will dig deeper into these container security. So the best practices which I'm listing right now. It comes under all these points, and we will be going deeper into these points later on. Once I will state you few Docker security things. So the best practices which I'm listing right now, it comes under all these points. So listen it very carefully, and later on after my session I will share all the blog links from where I have taken the references which I found useful in my case. So I will share all the blogs, all the links, Docker docs from where I have taken references and from where I study personally, which I found to be useful. Coming to the next best practice, which I would like to list, is that is very important. It is specify the amount of memory and CPU needed for a container to operate as designed instead of relying on an arbitrary amount. So please do this, specify the amount of memory and CPU needed for a container. So by default, Docker containers share the resources equally with no limit. So try to limit it out. Try to specify the amount of memory and CPU needed for a container to operate. Set the container's root file system to read only. Try to set the container's root file system to read only. Once running, containers don't need changes to the root file system. Any changes made to the root file system will be likely for a malicious object. So to preserve the immutable nature of the containers, where new containers don't get patched but rather created from a new image, you should not make the root file system writable. So try to avoid this thing. Try not to make your root file system writable. Also, coming to the very next important point is impose PID limit. So always impose the process ID limits onto your containers. So one of the advantages that containers is tight process identifier control. So this is one of the big advantage that container is having, that is tight process identifier control. So each process in the kernel carries a unique PID, and containers leverage Linux PID namespace to provide a separate view of the PID hierarchy for each container. So putting the limits on the PID effectively limits the number of processes running in each container. So if you limit the process number of processes running in the container, it will do, it will basically prevent the excessive spawning of new processes and potential malicious lateral movement. So if suppose you have put the limit of process ID to 10, so nobody will be able to attack onto your container and will regenerate the number of processes and will exhaust your memory. So the people try to do that. So it is better to set the PID, impose the PID limits. Mostly the benefit here, it will be that if your service always run on a specific number of processes, then setting the PID will limit to the exact number of mitigates many malicious action, including the reverse shells or remote code injection. So another point is don't configure your mount propagation rules as shared. Sharing mount propagation means that any changes made to the mount point will propagate to all of the mounted instances. So try not to configure your mount propagation rules as shared. If you will share your mount propagation, what will happen? If you are making any changes, so it will apply to all of the instances that are running onto your server. And don't uh, don't try to use docker exec command with privileged or user root options, since the settings could give the container extended linux capabilities. So please don't try, I can just say that, don't use docker exec command with your root option. And another important thing is, don't use the default bridge, Docker 0. Using the default bridge, what will happen? You will open a ARP spoofing and Mac flooding attacks. So try not to use the default bridge, and so that you can just avoid the spoofing. Instead, containers should be on a user defined network and not the default one. And coming to the last point over here is, don't mount your Docker socket also inside containers, since this approach will allow a process with the container to execute the commands that will give it full control of the host. So try not to mount your Docker socket inside the containers. So now moving on, these were the few best practices. Don't worry if you don't remember at this time. I will share all the blogs, all the links with you in the YouTube chat. If you have any question, post in there in the YouTube channel. I will take it afterwards, or Sayam Sangam are there to help you. Now, coming on to the PPT, I will give you a deep dive into each of these topics. So, as I mentioned earlier, set resources quota. So one handy thing that Docker makes easy to do is to configure your resource quotas on per container basis. As I mentioned earlier, so this is very handy thing to do in Docker. You can easily configure resource quota on a per container basis. So what basically it will do is, it will allow you to limit the amount of memory and CPU resources that a container can consume. So this feature is very useful for several reasons. One of the reason is, it can help you to keep your Docker environment very efficient and prevent one container or the application from hogging system resources. But also it enhances security by preventing a compromised container from consuming a large amount of resources in order to disrupt service or perform malicious activity. As I mentioned earlier, if you will set the amount of memory or CPU resources on a container, it will consume that much memory or CPU utilization, and it will surely uh, prevent the malicious activities. Another point which I would like to mention here is, don't run as a root. So I know you must be tired of listening this again and again, but if you don't want to fight with permission settings in order to get your application work properly, so just run it as a root. So don't have to worry about the permission restrictions. So that should be okay to do in a Docker testing environment if you are learning how to use Docker for the first time. But in production, never use Docker container run with the root permission. So this is the reason. So this is a easy Docker security and best practice to follow that doesn't run container as a root by default. So typically there is nothing you have to change in default to the configuration to prevent running as a root. However, have to resist the temptation to let a container run as a root simply because it's more convenient in some situations. Now coming to the third point, secure your container registries. So container registries are the part of the Docker, are part of the reason Docker is so powerful. So that is the thing over here, is why Docker is powerful, is because container registries are the part of the Docker. So they make it very easy to set up a central repository from which you can download the container images with just few commands, with just few keystrokes. So that is the whole thing over here. However, the ease and the convenience of the container registries can become a security risk if you fail to evaluate the security context of this registry you are using. Ideally, you'll use a registry such as Docker Trusted Registry that can be installed behind your firewall in order to mitigate the risk of the breaches from the internet. So that is the ideal thing over here. And if the registry is accessible from the behind the firewall, you should also resist the temptation to anyone upload to let anyone upload or download images from your registry at will. Instead, you what you can do is you can also provide role based access control to define explicitly who can access what. And also what you can do is you can blacklist the access from everyone else. Although it can be tempting to leave a registry accessible by anyone in order to simplify access, but try to avoid to configure such new roles. Okay, and then coming to the fourth point, that is use trusted secure images. So speaking of registry, you should be also be sure that the container images you pull from a trusted source. So always try to pull your container images from a trusted source. This also may seem to you be very obvious, but given that there are so many publicly available container images that can be downloaded quickly, it can be easy to pull an image accidentally from the source that is not verified. So don't so try to always pull your images from a trusted source, so that you don't end up pulling a image accidentally from a source that is not verified or trusted. For this reason, you should consider blacklisting public container registries other than official trusted repositories, such as the ones which are available on the Docker Hub. So you can take advantage also of the image scanning tools to help to which can help you to and identify some of the vulnerabilities within the Docker images. So try to use image scanning tools as well. Now, coming to the fifth point, that is identify the source of your code. So please keep in mind that the Docker images are typically contain a mixture of original code and packages from the upstream sources. So even if the specific image you download comes from a trusted registry, the image could incorporate packages from other sources that might not be trusted. So to make matters even more complicated, those packages could themselves be composed of code drawn from multiple sources, including the third party open source repositories, although the origins of the code may not always be clear from looking at the package itself. So now let's come on to the sixth point, that is API and the network security. So Docker containers typically rely heavily on the APIs and networks to communicate with each other. That's why it's essential to make sure that your APIs and network architectures are designed securely, and you monitor the APIs and network activity for anomalies that could indicate the intrusion. So keep an eye on the APIs and networks which you communicate with each other. So these were the few good best practices that you one could follow, and I will share few links as well in this. So if you have any doubt on these security things, so please go ahead and reach out on my Twitter channel I underscore Saloni 92. And these things are really very helpful when you are thinking to run your applications into the kernel. So what I'm going to do is I will share a few of good blogs or links with you, and so that you can go through each of the link, and I will paste the link also there. So as I mentioned earlier, you should restrict your CPU, GPUs, or memory. So this is very good docs.docker.com link from where you can go ahead and study more about this, how to restrict the memory and CPUs and GPU. So by default, a container has no resources constraints. As I mentioned earlier, you can use as much as of the given resources as the host kernel scheduler allows. So Docker provides ways to control how much memory. As I mentioned earlier, Docker. So please go through these links. If you have any doubt, reach out to me on LinkedIn or on my Twitter profile, and subscribe to Sayam Pathak YouTube channel for more free learnings. And yes, do post in the comments if you want to learn something about Docker, which I have not covered yet. I tried covering networking, security, and differences and what is Docker from very scratch, and tried showing you how to create your run your own container, how to create your own Docker file. But if still you have some feedback or suggestions from me, do post on the YouTube channel. So now with this, I will hand over to Sayam. Thank you so much for attending my session.